I am Jasmine Rishishija, Assistant Professor from AC Department of Rohini College of Engineering Technology. Now we can see the overview of today's section, that is the objective of the subject, outcome of the subject. Now you can see the syllabus and review of signals and system and the concept of frequency in discrete time signals and the summary of analysis and synthesis equation for FT and DFT, DTFT and the basic signal representation, and we can see the introduction of DFT. Now the objective of the subject, that is to learn the discrete Fourier transform, properties of DFT and its application to linear filtering. To understand the characteristics of digital filters, design digital IR and FIR filters and apply these filters to filter undesirable signals in various filter frequency bands. To understand the effects of finite precision at the representation and digital filters. To understand the fundamental concept of multi-rate signal processing and its application. To introduce the concept of adaptive filtering and its application to communication engineers. Now we can see the outcome of the subject. After the students, after studying this, they can apply the DFT for the analysis of digital signals and system, and they can also design the IR and FIR filters. They can characterize the effects of finite precision representation and digital filters and design the multi-rate filters and apply adaptive filters approximately in the communication systems. This is the syllabus, the first unit, and this is the textbooks and the reference books. Now we can see the review of signals and systems. First one is signal. The signal is defined as any physical quantity that varies with time, space or any other independent variable. And the types of signals are continuous time signals, discrete time signals and discrete time signal. Well, we are seeing the continuous time signal. The continuous time signal are continuously vary in accordance with the time, and the continuous time signals are continuous in amplitude and time. They are denoted by x of t and the examples of sine wave and cos wave. Discrete time signal, it is defined as discrete time instance of time as known as the discrete time signal. The discrete time signals are continuous in amplitude and time, discrete in time, and they are denoted by x of n. And the examples of discrete, that is the electrical signals derived in proportion with the physical quantities such as temperature, pressure, sound, etc. While we are going with the system, a system is defined as physical device that generates a response or an output signal for a given input signal. This is the system. It gives the input and gives the output. The types of systems are continuous time system and discrete time system. And here, this is the first one. In the case of continuous time system, if we are giving the continuous time signal, it processes the signal and now produces the output. In the discrete time signal, they just process the discrete time signals. The continuous time signal, this is the equation for giving, that is x of t is a cos omega t plus 5 when t varies from minus infinity to infinity and omega equal to pi f. In the case of discrete time signal, it is given as x of nt, that is a cos omega nt plus 5. And here the analysis and synthesis equation of FT and DFT. First we are going to study about a Fourier transform, next discrete Fourier transform, and next one is the discrete Fourier transform. It is a bridge from time domain to frequency domain, and also DTFT and FT are arbitrary chain sequences, which are the DFT can be applied only to finite length sequence. Well, we are going for this Fourier transform, the analysis equation. The Fourier analysis equation for the signals x of t is defined by the given equation, where t is the index to time, which units of seconds, then f is an index to frequency, which units of cycle per seconds. And the synthesis equation of the signal x of f is given by the equation below. And next one is the discrete time Fourier transform analysis equation. The DTFT is a transformation that signal x of n into a complex values function of a real value omega, and the equation is the analysis equation is shown by the equation below. Next one is synthesis equation. The discrete time Fourier transform synthesis equation of the signal x of omega is given by the equation shown below. But we are going for the basic signal representation. The signals are represented by using the different types, that is unit step sequence, unit symbol sequence, ramp sequence, exponential sequence, and they are also available in both continuous as well as in discrete forms. In the case of unit step sequence, the unit step sequence is given as step sequence function is given as u of t equal to 1 for t greater than or equal to 0 and 0 for t less than 0. In the case of discrete time signal, u of n equal to 1 for n greater than or equal to 0 and 0 n for n greater equal to 0. And in the case of impulse signals, and in the continuous case, it is defined as del of t equal to 1 for t equal to 0 and 0 for t not equal to 0. For the case of discrete, del of n equal to 1 for n equal to 0 and 0 for n not equal to 0. And the ramp signal r of t equal to t for t greater than or equal to 0 and 0 for t less than 0. R of n equal to n for n greater than or equal to 0 and 0 for n less than 0. But in the case of continuous signals, c equals the signal, the exponential signal is denoted by g of t, that is g of t equal to a into e power dt, where a is greater than or equal to 0. This is the waveform for showing the continuous time signals. And the discrete time signal, the exponential signal is denoted by g of n, by g of n equal to a e power b power n, where a is greater than or equal. This is the representation of the discrete and exponential signals. And while we are going for this discrete Fourier transform, the discrete Fourier transform converts a finite sequence of equally spaced samples of a function into a same length sequence of equally spaced samples of the discrete time Fourier transform. It is a complex value function of frequency, and also the DFT is said to be frequency domain representation of the original sequence. And this is the DFT fast, which is formed by the DFT is the first equation and the IDFT is the second equation. These two equations are called as the DFT fast. Thank you.